what quantum chemistry is for dummies. Quantum chemistry is the part of science that tries to explain how atoms and molecules behave using the rules of quantum physics. Instead of thinking of electrons as tiny balls orbiting a nucleus, quantum chemistry shows that they behave more like waves, existing in probabilities rather than fixed paths. To understand this more easily, imagine a simple idea. In classical chemistry, you might picture an electron moving around the nucleus like a planet around the sun. But in quantum chemistry, this picture changes. The electron is not in one exact place. Instead, it exists in a cloud of possible locations. Scientists call this an orbital. A helpful experiment to understand this idea is the double slit experiment. In this experiment, tiny particles like electrons are fired at a barrier with two small openings. If electrons behaved like solid particles, they would pass through one slit or the other and form two clear lines behind the barrier. But something surprising happens. Instead of two lines, a wave-like pattern appears. This shows that electrons behave like waves, spreading out and interfering with themselves. Even more interesting, if someone tries to observe which slit the electron goes through, the pattern changes. It starts to behave more like a particle again. This tells us that at a quantum level, observation itself can affect behavior. Quantum chemistry uses this idea to explain how atoms bond together. For example, when two hydrogen atoms come close, their electron clouds begin to overlap. Instead of thinking of electrons as belonging to one atom or the other, quantum chemistry describes them as shared between both atoms. This shared region creates a bond, forming a hydrogen molecule. Another important concept is energy levels. Electrons cannot exist at just any energy. They can only occupy specific levels. A simple way to imagine this is like steps on a ladder. An electron can stand on one step or another, but not in between. This can be seen in flame tests. When certain elements are heated, their electrons jump to higher energy levels. As they fall back down, they release energy in the form of light. Each element produces a specific color. For example, sodium produces a bright yellow flame, while copper can produce a green or blue color. Quantum chemistry explains why these colors are different, based on the structure of each atom. In larger molecules, these quantum effects determine shape, stability, and reactions. For instance, the shape of a water molecule is not random. It is determined by how electron clouds repel each other and arrange themselves in space. This is why water has its unique bent shape, which leads to many of its special properties. In simple terms, quantum chemistry helps answer questions like, why do atoms bond? Why do molecules have certain shapes? Why do reactions happen the way they do? Instead of giving exact positions, it gives probabilities, patterns, and rules that describe the invisible world at a very small scale. Even though the ideas can seem unusual, they allow scientists to understand and predict how matter behaves, from the smallest atoms to complex molecules. Quantum chemistry is, in essence, a new way of seeing the building blocks of everything around us, not as fixed objects, but as dynamic systems shaped by probability.